All right, so we're doing intro to software testing. The first item here, we're talking about qualities that you should have as a QA engineer. Number one is critical thinking. If you test an application and somehow everything seems good to you, somehow you're not finding any issues, you might not be thinking critically. You want to ask questions. You want to be really curious why the application working the way it should, right? Or the way it is working now. Is it proper? Is it something that is happening according to the requirement, right? We do have a checklist as a QA engineer. When we create the checklist, we think critically. We don't just go ahead and um, just look at the requirement and just pretty much copy paste. That's not how we work. We understand the requirement. We understand the product. We understand the software before we write our checklist, which is ultimately going to be a test case. The next item is patient. If you ever found yourself with a pop-up message and you didn't read and you click OK, that's the personality we will remove by the end of this course, because we want to read everything. We want to understand why this pop-up showed up, what it is the pop-up wants. Is there any spelling error within this message, within the pop-up? If there's any extra space, does it look good? Is it covering the whole page? That's something that we will focus, right? We want to make sure that we're not just go ahead and click on that OK button because we want to move forward. We want to go into the next. We want to already jump to the final section, right? We don't want to do that. We want to make sure that we are patient when it comes about testing. Then we have attention to details. And the details part is, again, our only job. These are some qualities that I'm describing here is really, really relevant to our job. Being patient, attention to details is something that, we get paid for, being flexible, being able to communicate and quick to learn, right? We get paid to have this kind of personality. Think about what would be the difference if you test a software versus somebody who just graduated from not even college, maybe high school. What would be the difference, their thinking process and yours? So I'll take a question from Maria and then continue with the slide. Go ahead, Maria.
Sorry, so you meant patient or patience?
Patient. Okay, patience. I
Sorry.
was actually, okay, I'm gonna go ahead and update this. That's really, really good attention to details. I think I added this slide like last minute, like before the class. I do have remaining slides. But anyway, I added these slides because we want to make sure that we talk about the qualities that you should have. And that was a good one, right? That was a test, by the way. And some of you guys didn't pay
But thank
attention.
you.
I'm just kidding. That was my mistake
Could be
as I
type
was.
mistake. Yeah, I
Yeah.
understand. Could be type mistake. Yeah.
All right. So think about this way. You need to be very much the person who is going to pay attention to details. Developers should be scared to send their work to you for testing. Why would I say scared? Is because they will think that you're going to go ahead and fail the story and say, okay, this is not working and that is not working. Imagine I'm a developer and I send you guys my work. While testing, you find 20 things. I will probably turn off my computer and just go to bed right away. Oh my God, this person is finding too many stuff. She's finding this and that. And that's how it may sound like to the developer, like, wow, it's too many things coming, right? So you have to also make sure that your patients, you're able to adopt to somebody's personality and talk to them and say, hey, here are some issues. Let's talk about it. Let's see how we can fix those. So the excellent communication comes in to work at that point, to make sure that you always communicate well, and also quick to learn, because as a tester, you may use tools from one company, you may use a tool which is different, and then another company, you may use another tool which does pretty much same thing. It's just a two different brand, maybe two different kind. So be able to learn those tools is really, really important. Collaboration and social skills. You don't want to be the person who's doing everything and not able to collaborate, right? So let's say somehow you're taking the ownership, somehow you are the person who's really care about the product, or somehow you're in the team, you feel like you really, really need to do, your job because somehow everybody else is not doing their job, right? How do you kind of distribute that kind of load? Because now you have too much work, right? So the quality will suffer. When you do too many things at the same time, the quality of your work may suffer. So how do you collaborate, and how do you actually make sure that, you don't just go ahead and do everything, right? So that's why collaboration and social skills really, really important. You want to let the team know that you need additional help. You want to work with the remaining team members. You don't want to basically give them the fish. You want to help them catch the fish at this point, right? When it comes about testing, we're going to start by talking about bugs, right? And that's the next topic. And this is a story that I would like to tell, and every QA and software engineer should know about this story. In 1947, Harvard University, they had a room size computer. As you guys know, back then, the computer is really, not scaled down to today's, laptop or desktop. And the maintenance of the software is actually physically going into the room and replacing parts, replacing tubes, and any sort of, chips or vacuum tubes, it should have been replaced like physically. So the computer is called Mark II, and our first software bug was found when a moth, and I don't know if you guys know what moth is, not the picture in the middle, but on the left side, the mean looking bug. It looks kind of like that, but on the right side is the real the actual bug that was found. And the bug, that's a bug report in writing. Okay. So a moth flew into one of the relay of the computer, and it got electrocuted with the high voltage. And this was the first computer bug ever to be recorded, right? To be known. So this is not a made up story, guys. So this is something that you can probably, I don't know how many people actually know about this story, but this is one of the story that everybody like to tell when it comes about software bug. Okay, so with that said, let's move on. And the importance of bug is because when we do test, when we actually spend our time to think critically, be patient, and kind of come up with a checklist to test all aspect of a feature and functionality, our end goal is to actually detect and find bugs. Okay, so that's why we're going to talk about bugs for a bit. The next one is, what is a bug? Because you need to really, really know what bug means to you. So a bug can be a defect. It could be a fault. It could be a problem. It could be an error, incidence, anomaly, variance, failure, inconsistency, product anomaly, product incidence, and feature. Okay. Now, with that list that I just mentioned, it seems like everything will be a bug, right? So it's safe to assume everything is a bug unless it's proven it's not. Okay. It's the other way how law works, right? You're not guilty until it's proven. But here we're saying you're guilty until it's proven, right? So it's the other way. Just have that kind of mindset. It's okay to just kind of like think this way. A software is not going to mind, and we're not violating software's, you know, pretty much rights, right? Because they don't have feelings. So that's great. Now, so with that said, like a bug is a defect, fault, problem, error. So now if you are given a checklist, if you're given a requirement, for example, let's say the requirement is to create a login feature. Somebody just can log in. And now you're testing and you see that person can log in, but also they can log in from using their Google account. They can also log in using their Twitter account, for example. Two different. Isn't it nice? Yeah, this is two extra feature. They're nice, but that is still a bug. That is still a bug because those extra features are not mentioned in the requirement. So to you, it's a bug. Okay. That is an example of feature, the last item. Then inconsistency. Sometimes the requirement doesn't really talk about everything. When you go to Facebook and you see the buttons, they have colors of those buttons. For example, let's say all of the buttons have similar consistency, which could be blue color with white text. Now, all of a sudden, a developer finished his work and he sent out to you for testing. And it was to, let's say, create a like button, for example. Somehow, yes, it meets the requirement, but it doesn't meet the consistency. The rest of the software doesn't really take that well. It's not suitable. It doesn't look good, right? That is still a bug. Then we have the failure. Failure is basically that it'll be really obvious, right? You click on a like button and it didn't really do what it should do, then it's really a bug, right? So these are obvious. I just wanted to talk about inconsistency and feature. The other problem is that when you look at the usability, when you look at the software and you feel like it could be improved, is that a bug? I don't think so. That is not a bug, but that doesn't mean that you're not going to go ahead and work with your team. If you feel like something can be changed and improved, then you talk to your team and see if you can change their mind. And that's one of the reasons why you are there on the first place. They're not just gonna hire you, or they're not just gonna basically get a QA person just come in and find bug and no. It's not a binary option here. Okay, I found a bug and done. My work is done. That's it. You want to improve the product. You want to use your expertise because you will be the person who has the knowledge about the entire product and software. So you want to make sure that you provide that kind of expertise to say, hey, I feel like this specific button is not suitable for how everything else is. It doesn't match with everything else. Can we change that? Or you give more suggestions, and then your team will then take those suggestions and make changes based on that, right? So we don't really just say, okay, it's not my problem. It's not on the requirement. It's not my problem. Done. We don't go like that. If it's not on the requirement, we bring it up. We still bring it up and say, hey, is it worth talking about? Is it worth spending some time and see if we can do something better? And that is something that you will bring in to the table. All right, so anybody here have any issue understanding what a software bug is at this point? It is pretty clear that everything is a bug unless it's on the requirement, and including all of these bullet points here, right? So, all right, so it's really important that you understand what bug is, and then the next slides we're going to talk about some real case scenarios where these bugs actually was severe in some of the cases. So now you may think, wait a minute, why we even have bugs, right? Is the software defective? And why do we create a program, such programs with flaws? You know, how many are there? What, you know, which kind? So it's really, really hard for anybody to predict. Otherwise, this job would not exist, right? The reason why they need us is because we are the one who's going to detect those flaws. We're the one who's going to find those bugs, and we're the one who's going to basically create those bug reports. Do we fix those bugs? How many people think we actually go and fix those bugs also here? Anybody think that we will also fix those software bugs?
No.
Raise your hand if you
No.
think. Right. So if we have to find and then fix, you may find less. Okay, that there is a bias here, right? Because over the time, somehow you found, bugs and you have to fix, then you may find as less as possible. Now, because you're fixing the bugs, you are a developer, right? You're doing developer's job and QA job. Now it's pretty much going down to the same loophole at this point. So now you're a developer and you're doing QA. The QA should be unbiased, the QA should be independent, and the QA should have as much as time they need in order to do the testing, because it is quite important. And that's why when you work in a team, nobody should rush you. If they rush you, you tell them you will not compromise in quality. Okay. And that's another reason why, as a QA person, you will feel that the job is a little bit laid back in the very beginning, is because you are not doing, you're not doing, I would say, more critical thinking. You're not really going in and digging until find some issues and bugs. In the beginning, it takes a little bit of time for you to get adjusted to that kind of mindset. So I would say the safer way to start your first job is, when you didn't find a bug, test it again, and then test it 2 more times. And then if you didn't find any bug, then maybe we're good, right? But when you become an expert over the years, it is going to be easier. It'll just get easier for you to find those bugs. If the bugs were very obvious, then you wouldn't even see that. The developer, they would find it themselves before they hand their work over to you. Developers already have done some testing. Okay, so it's really not going to be obvious. It's really not going to be severe, meaning you go and you click on it and all of a sudden everything breaks. That's dramatic. That's really happens in movies. Real case, I see rarely. It is rare to see that kind of issues. Okay, so that's why we're there. Software, defective software is not the, it's not an intention. It's basically, we're trying to build a software, but we are also trying to make sure that the software is bug free and it meets the quality standard, and it meets the user pretty much acceptance or user criteria of and the user expectation. The next one is, let's talk about some of the problem. How do you, and this is really going to give you a different mindset and will help you find those bugs. So let's talk about source of problems. How do we really, what should we think when it comes about detecting bug, and really where the origin of bugs, right? So requirement definition is one. We talked about Agile last time, and we'll get back to that. The last 2 classes that we cover a few things, we're going to actually repeat those, assuming some of you guys weren't there. So requirement definition is, what is requirement? Who can tell me what is requirement first before we even talk about? All right, so let's pick somebody.
It's
Go ahead.
what the BA created for the product to I'm sorry. It's basically the necessities for the product that we want to create.
So it's like a user story. Like, hey, as a user, I would like the website to accept friend request. And, we're talking in terms of Facebook, is because everybody knows Facebook. So whenever we talk about Facebook, just pretend that it doesn't exist and we're coming up with the idea. Now, a requirement could be a user story, and you would write it, oh, as a user, I would like to log in to Facebook and be able to see my friends, right? That is a requirement. So in requirement, it could be incomplete, inconsistent requirement. Sometimes it is ambiguous, meaning it says that in the homepage, I would like to have, let's say, Twitter and Facebook, oh, sorry, Twitter and Google icon. So that way customer can see that they are able to log in through Twitter and Google account. Now, it doesn't say where it should be. It doesn't say how it should be. It doesn't say the, size of it. It doesn't really say it should be in the top, it should be in the bottom, nothing. You're going and you're doing the testing and you find those two icons and you go ahead and say, oh, okay, it's there. Requirement says it's there, so it's good to go. But really you should be asking the question as a critical thinker, is that, okay, wait a minute, what about the size? What about the color? What about the location of those two icons? What about the functionality of this icon? What if somebody clicks on it and then decides to go back and not use those two icons? These are some questions that you start to ask and get those answers before you do your testing. So sometimes requirements, and you may think, oh, wow, in a commercial environment, a requirement could be that, poor. Yes, sometimes it is that poor is because we're developing on the fly. Every 2 weeks, there is new changes, change requests, there is new user stories. So sometime a product person, a product owner will say, hey, I want this. And then business analyst will go ahead and quickly write that up and send it over to the team. Can we develop this specific part of the application? Excuse me, guys. And then once the developer gets it, majority of the question developer asks because they have to develop it, right? And they know better, because if they didn't ask this question and they do it based on their understanding, a QA may actually understand differently and now there is a bug, right? And you want to make sure that you are part of that communication. When developers goes and ask this question, you want to make sure that you are actually aware of those changes, so that way you can add it to the story. So remember, if it's not in the story, developers went and spoke to the product and they actually agreed, but it's not in the story. Is that still a bug? Because by the time it came to you testing, that piece of information the developer already have outside of the user story, and you don't see that, is it still a bug? Yes, it is, because if it's not in the requirement, it's a bug. Done. You're missing, let's say, a period at the end of the sentence, and your requirement says the sentence as is basically does have a period on the requirement. It is very minor. Do you still raise that as an issue, or do you just go ahead and say to your developer, hey, a period is missing, I'll let it go, but next time try to basically add it? Is it safer? Is it okay to say that? The answer is, that means you're just not doing your job, because if you're not critical about the issues that you find, then who will, right? If you're not making a big noise about those issues that you find, then who will? That's your job. If you're not making a big deal out of everything, then who will? So our job is to find issues and make it as big deal as it can be, because it is a big deal. It is a significant deal for a company for this kind of errors. If this period is in a contract, for example, the company creates contract and they send out PDF, somehow this period is missing and it went to the next line, and now the contract, basically the verbiage changes, the way the contract is stating is changed because of that period. Now the company could be losing millions of dollars by lawsuit or any other means. So that's why it's very, very, very important that we compare with the requirement, we understand the requirement, and learning about the product is 100% your first priority before you can even do anything in a team. Design is fundamental design flows in the software. Sometimes you'll see designers, even they are making their mistakes, even though, you get the design document and then you look at it and it doesn't quite sound or look the same. A developer coming to you and say, hey, yeah, it looks similar. It's just that I couldn't go as far as, what they wanted. Is that a bug? Yes, it is. Developer may say and explain to you, it cannot be done because this and that. That's none of your concern. If it cannot be done, it's fine. If you have to still create that bug. So that way the rest of the team knows that there is a limitation in technology, but that is still a bug as your concern. Implementation, mistake, cheap fabrication. We got wiring, programming fault, and malicious code. Sometimes developers, they want to do the work quickly. They don't want to do it properly. So they put layers in top. For example, you see a specific part of the application. Maybe you see a button and it shouldn't be there. Now, somehow developers say, okay, sure, I'll fix it. 5 minutes later, he has a fix, he pushed it and you look at it and it's not there. But what he did is that he just go ahead and, made that button invisible by changing everything to white, the color, the background and everything. You don't see it physically, but if you click on it, it does work, So that's not a proper fix. And that is basically a recipe for disaster if that goes into production and actual user is facing the same. User will try everything they can in order to advance themselves, right? If you, let's say Facebook is charging you guys $5 to log in, and that register button is invisible until payment is made, let's say, and somehow it's there but it's invisible, but people found out about clicking on that specific corner of the application will let you log in for free, then people will do it. We just don't have that kind of control over end user. Okay. The next one is support system, poor programming language, faulty compilers, debuggers, misled. So these are coding issues that will take place. So we really can't assume that developers will not make any mistakes, because these things is out of, sometime it will be out of their hand, right? So they did their code properly, but then the compiler has an issue, right? And the tool that they're using have an issue, right? So maybe when they are developing on their computer, they seen everything works properly, but when they push the code to a server, it doesn't, because locally in their machine, things are done properly, but not in the server. So either way, server issue or code issue, we have to basically be open-minded about these problems. It can come from anywhere. So it is safer to say everything is a bug until it's proven. Again, the reason I say that is because when I joined my first job, I felt like everything is happy and healthy. Everything works properly. So I think Roman has a question. Go ahead with your questions. I'll move on to the next slide after this.
Hi, this is.
Oh, there's a lot of echo. You can also write down the question if you have a lot of echo, and then figure that out later.
Can you hear me?
Yeah, I can hear you. What is your question?
My question is, as a QA, right?
Mhm.
Are we also kind of taking a look at the design? Are we just doing the technical part of affair? I mean, looking at the bugs at a technical level.
That's a great question, and thank you for that, guys. Just like that, if you have questions, always ask, because then everybody benefits from the questions. So as a QA, it really means that overall quality of the software, if that could be design, if that is the look and feel, UI, and the functionality also. We do all of it, right? We want to make sure that the software meeting the user need at the end of the day. It is. So the answer is yes. And that's why they create the design document. Design document is something that is used by a developer to match exactly what the designer wants. because remember, the design document already went through few approval process. Somebody had to look at it and say, okay, yes, this is how I want my feature to be. I want my application to be. So we already know design has been approved, and the end customer or the product owner already looked at the design and says, okay, this is great. This is how I want it. So it will make sense if we raise that as a bug if it doesn't meet the design as well. Maybe it's working fine, but design looks horrible. The developers come to you and like, who cares about design? You know, it works. And you're going to say, all right, that's great. Let me create few bugs. And then you start to create bugs like, okay, there is a design issue. This and that doesn't look the same. And you provide 2 screenshots comparing how the design wanted and how it looks actually. And then you work with the rest of your team. There is no aggression. There is no fights here. All you have to do is talk to the whole team and say, okay, what do we want? Maybe the team will come back and say, okay, for now, let's ignore the design and it's working. So let's continue. Or they will say, wait a minute. Thank you for letting us know. Even your design team will say, wait a minute, how come you didn't tell me? If you, let's say you agreed to that kind of change and you said to the developer, hey, it's fine. All right, thank you. And now the rest of the team is going to look at you like, how come you let it go without letting us know? So you are the gatekeeper. Okay, you are the person who's going to say, pass, you're going to seal your stamp and say, everything looks good. That means everything is based on the spec. Okay. It is going to be quite embarrassing if you let things go and say it passed and UAT tester or somebody like product owner, they said, okay, let me look at it. Second specify, see, this is exactly how we wanted it. And they're looking at it and they really, really think that there is significant amount of issues. That means you haven't done your job. So that's why it is 100% friends or not friends. You don't let go anything that you find. Matter of fact, if you do find issues in somebody's code, you actually helping them to become better the next time, right? So you're really gradually helping developers to be really, really mature about writing their UI, design, programming, and all of that. Whatever mistake they're making, they will not make the mistake again when you find and point out to them to fix those. But also you're giving a very good impression to the overall team that yes, you are really, really a gatekeeper. And then also the developers will understand that if I just start sending these stories, this is going to fail and come back. So let me just go ahead and do a round of testing myself to make sure nothing is there and then send it out to the person, right? So that's another good impression that you can provide to your team. Source of problems continues. Inadequate testing of software, incomplete testing, poor verification, mistakes in debugging. So when you do your testing, you don't think like a user, right? You don't think like a tester. You don't think like a developer. And that's where you're going to be finding yourself doing poor verification, incomplete testing. So for an example, right? From here to Manhattan, you are testing to see how many possible way can you get there. You took a train, you took a bus, let's say bus and train combination, you went to Manhattan from Queens, and you call it a day. Wow, okay, that's it. This is how I can go. But what about somebody who will take a bicycle? What about somebody who will take a bike and a bus? What about somebody who will take bike, bus, and train? What about somebody who will actually walk, right? So you have to really, really look and find every possible aspect to make sure that you have proper test coverage. If you have incomplete coverage, some user will try that after release, and now your team will come back and say, okay, did we not cover this? Did we not test that? And you're going to say, wow, I didn't really think about that. I really think about people who do this, right? And now you also have to know when to avoid a scenario. So for example, the same example here, going from point A to B, Manhattan, from Queens to Manhattan, you testing a scenario, somebody's going to take a jet from here to Manhattan, the chances is unlikely or is unrealistic. It cannot be done. You don't test that scenario if it's unrealistic and cannot be done. If the user cannot actually interact and do that exact thing, you shouldn't, right? Because then user is not able to do that anyway. The second is if somebody's going to take a helicopter from Queens to Manhattan, and the chances are, yes, once in a million, do you test that? The question here is that, do you have enough time to test that? So if you do, then you cover that. Otherwise, you can also let them know there are some edge cases. Edge cases means that these are really, really, some scenarios are really highly unlikely, but they're something that user will be able to do. So you basically then make a determination you should test it or not test it based on the time, how much time you have for testing. Evolution, sloppy redevelopment or maintenance introduction. And this is actually does happen in workplaces, is that, one second, guys. All right. So evolution, basically what happens is a developer wrote his, he did his feature, it looks good and everything. And then down the line, that exact feature needs a new part. You want that feature to be more, precise, or maybe adding more features or functionality to it. And a new developer comes in and he started to introduce those new features to existing feature. And now he's really, really making that more, complex, as well as it's making it user friendly, not user friendly at all. And that's where you have to jump in and say, wait a minute, if I am the user right now and I interact with this feature or functionality, and I feel like it's giving me a headache, I think the millions of customers that we have, they will have the same headache. Now, you can also probably think about something like this. If you have to go through 4 different clicks to, let's say, make a payment, right? Let's say it's Chase Bank and they want people to make payments, and it has millions, if not billions of customers. And the developer created a feature that requires, before it used to be like a single click pay, and it did the payment. Now, if you click pay, it says, are you sure? And then continue. And it says, okay, now give me the 4-digit of your, bank account where you want the money from, even though the account is already linked. And then once you click OK, then it will say confirmation one more time. Okay, so here's your bank account. Here is this information. You're making payment today, and it will post it tomorrow, blah, 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 blah. And then it will ask you to confirm. And now that 4 click requires, let's say, 5 extra seconds per customer. 5 times 1 million if 1 million customers are affected by this new feature. And that's a lot of time that they have to spend to make payments. They will see a trend quickly that some people are not even making payment through websites. Some people are making payment, but it's taking significantly long time. And some people are getting tired of it, and they're just going directly to the bank. But you as a tester, do you really approve this kind of feature? When you realize this is a headache for the customer, you're going to speak up. You're going to say, hey, I have a suggestion. I'm also a customer for Bank of America, and I don't think they do this, right? I don't know why we're trying to make the customer's life really hard by having 4 different clicks in order to just make the payment, right? So you're going to basically think about efficiency. You're going to think about the technology they're using and how they are allowing customers to navigate through the application and provide your assessment. You're not just there to say it works and it doesn't work. Okay, you will be part of the team, and you will be bringing those issues to the whole team, and you will be setting up those meetings. You find this kind of issue, you gathered all the information that you can, and you list out some of these issues that you found, set up a meeting with your team and talk to them, and then explain one by one. And if they said, okay, no, this is how we want it, then that's great. That's great. You did your job. So suggestion is something that you want to bring in when it comes about finding bugs and issues. So these are some sorts of problems that you will face in while testing. Adverse effect of faulty software, right? What happens when you really like have faulty or any sort of software bugs? What kind of impact that will create for the end user, that will create for a company, right? Because there are different kind of softwares. For example, one is, it could be open to general public. The whole world can sign up and join, like Facebook. The other one could be internal softwares, meaning only employees use them. And the other ones could be, more related to the, the hardware itself. So it could be a jet, it could be even a machine that uses the software to make determination, right? So now let's talk about the effects that it can create. So loss or corruption of communication or media. So this really, if there is a software issue, and for example, Chase Bank, there's a software issue where you make a payment and it doesn't give you a confirmation, and it leaves you on basically, it leaves you with nothing after making the payment. And payment does take a little bit of time to process, and immediately you log into your account and you see that the amount that you just made payment, it wasn't decreased from your original amount. You're panicking. Oh, where did my money go? You started calling the customer service. And that is not a mistake that you're making this call. You have the right to have this kind of concern as a customer. And you started to call the customer service. Now the customer service team is really busy. It's a really good job security for them, but at the same time, they can't handle, right, all these calls. Now people are waiting 2 hours on the line, and all of a sudden you see many reviews going out the internet saying Chase is this and Chase is that. They don't care about the customers. It's been 2 hours I'm waiting. My payment didn't go through. The next day payment went through because it took 1 business days, for example, and they're fine. But in the meantime, all those comments that they made online, it cannot be reversed. So that's really affects a company's image in terms of customer service. And that's just a single example. Then we have the space application. People would die because of software bugs. Things can really put people's life into question when it comes about software bug if it's not tested properly. We got defense and warfare. Misconfiguration can really, cause even a war if something really were to happen. So that's why your job is really important to a company, to any sort of entity that uses software at this point in order to stay afloat. All right, the next one, again, transportation, safety applications, electric power, right? So many things can happen. Transportation, death, sudden acceleration. Let's say you have driverless train for some reason, and there are software issues with it, right? People can actually be injured or die because of this kind of incidents. Critical software, safety critical application. So that could be like, let's say, LASIK surgery, right? I don't know, some of you guys probably went through that. If you get your eye corrected by LASIK, and all of a sudden the software goes nuts and start using the laser wrong way, you're gonna end up losing your eyes. If not, you potentially could die if the dose is really high. Then electric power, very similar. You get the picture at this point in terms of faulty software. Money management is the big problem here. If you're into finance domain, it really don't play about software quality and assurance. They will hire as many as QA as needed. They need to. They will test it. You will basically find everything is an issue, everything at all. You don't want to let anything go, and then have a huge problem after release. There are other examples like elections. We have control of jails, for example, and law enforcement. These are some areas where software is being used in order to handle or properly manage their everyday work, everyday duties. And if we have a software issues, then it will really create problems that will affect real world people for with their lives and wealth. Okay, so let's look at some of the example that in the past what happened, right? And this is really something that you need to understand in order to know the significance of finding bugs, or at least software bugs. Number one is in here. So these are actually in the internet, right? And you can also look them up. These are not something that we came up with, or these are not something that I'm coming up with to tell you a story. These stories many people are telling online. 2015 fighter plane F-35 fell victim to a software bug, making it unable to detect target correctly. And you may have guessed what really happened next. They might be shooting into wrong targets, right? And killing innocent lives. China Airlines Airbus A300 crashed due to a software bug on April 26, 1994, killing 264 innocent lives. Okay. I don't know if they had QA into that team, whoever tested the software, but it's tragic, right? It's really tragic. If they didn't use the QA, if they did use QA, that may not even happen, right? I don't think in 1994 they even had the role QA. They may have developers who did the QA at that time. Assumption, I don't know. I wasn't there, right? So now, in 1985, Canada's Therac 25 radiation therapy machine malfunctioned and due to software bug, and delivered lethal radiation dose to patients, leaving 3 people dead and critically injured 3 others, right? And then there are few more examples. In April 1999, a software bug caused failure of 1.2 billion military satellite launch, and this is one of the costliest accident in history. And the last one that I'd like to talk about is in May 1996. A software bug caused the bank account of 823 customers of a major US bank to be credited with 920 million US dollars. What do you think is going to happen? People are going to take out the money, and then it'll take years to litigate and get those money back. Some people would be honest. Some people would basically would spend it and say, okay, I don't have any money, I'll do bankruptcy. It's all of that. To recover that money is going to require more money, right? So it is quite important what you will be doing for a company, no matter what kind of domain that you will work in and what kind of company that you will be working in. So it's really important that you kind of sink that in and understand you're important. You will be an important person in a team. Anything that you say, they will value. Anything that you will ask, they will look into. And if you're not passing, nobody's going to push. So let's say you're holding onto a story and you're saying, okay, I'm not satisfied. It'll go nowhere. Nobody's going to say, pass it for me. Nobody's going to say you're going to get fired because you're holding this story for such a long time. You're going to only answer in a way saying you're not going to compromise quality by trying to do quantity, which is you are trying to get as many as story done. Instead of getting too many stories done, you're taking your time to make sure that it meets the standard before it going forward and going for release. So you are the last person as a gatekeeper, because the UAT testers, they just eyeball it. They don't really do thorough testing. You are the person who will be doing really deep testing to make sure that everything meets the criteria. All right, let's have a discussion. I talked a lot for the last 5-6 slides. So let's have a discussion right now about any software bugs that you ever heard, and this is just to have some engagement here. And the next question would be, does this really embrace you as a future software QA engineer, and QA engineer? So if you're meeting somebody on the street and they said, okay, what do you do? I'm a QA engineer. They will not understand what QA means. So it is safe to say software engineer. After all, you're part of the development team. It is okay to say that. So now my question to you guys, there is two questions here. One, if you ever heard of bugs, you know, in the media, had personal experience when you use the software, and then how does these slides, this conversation that we had today, helping you to say, okay, this is something that I want to do. You know, this signifies, is this give you enough cause? If this gives you enough motivation to say, I want to do this, I want to actually, you know, pursue in this kind of career. Obviously, people that are in this group, you guys already here because you want to pursue this career. But I'm just saying, does that increase the interest so far? So we're going to start with Roman. I think you.
Hi, can you hear me?
Yep, I can hear you.
So I have a quick question, not about the discussion part. The
Mhm.
question is, so you are the gatekeeper, so you check the software, everything looks fine, and you release the software.
Mhm.
So after, let's say, another month or two, the bug appears, because sometimes software can acquire bugs while outside of development period, right?
Mhm.
So what is the time frame for a QA to be penalized for that? Like, let's say you checked the software, it was okay,
Mhm.
was bug free, but it was released, and somehow it acquired a bug while used by user. So just wanted to know, like, what are the time period when QA are penalized and not penalized for this kind of situation?
That's a great question again. So when we release a software, we do testing in QA first, then it goes into UAT, and then UAT do their testing. So developer do their testing before they're giving it to us. So 3 layers of testing goes in. Then we do our testing. We do really deep testing, find issues, get it fixed. Then we send it out to the UAT. UAT do their part of the testing. And then they said, okay, they're okay with it. And then QA manager comes in and talks to you and say, hey, everything good? And you're saying, yeah, everything seems okay. And then QA manager goes, okay, here's my, you know, ready to release authorization. QA manager signs off and says, okay, we're good. It goes for a release. And then you come in again, because during the release, it could happen in the midnight. It could happen on Saturday, on Sunday. So it never happens during business hours because they don't want to disrupt the customers who might be doing business at that time. So your team will ask you to be available either midnight or on the weekend, once in a month, or at least twice a month. And they will compensate for that. They will probably pay you extra time and a half, maybe. But so in that time, what your job is to observe the deployment, the release process, and then you want to assist the team on testing after the release took place. So release happened already, and now your team is saying, hey, we have everything live right now. Can somebody go and verify? You're going to go immediately to the application. You're going to immediately retest those scenarios that you tested early. And you're going to give them an okay to say, okay, sorry, guys. So you're going to basically give them your okay to say post-release validation is completed and there was no issue. That means you have tested after the release is done and there is no issue. Now, that doesn't mean that user will not find an error or bug. Within 24 hours, if the user finds a bug, or within the first week, if the user finds a bug, that will not be as severe because you already did the post-release validation. It cannot be severe. If it takes a very long time for the user to detect a bug, for the user to complain about the bug, that means it's not an immediate, that's not a critical, it's not a high priority bug. So there may be low priority bug coming even after a week. Are you going to be penalized for that? I don't think so, right? You're going to say, oh, what? Okay, this is something that we can look at and learn because this is, you know, this can happen. We will keep that in mind on the next time when we do the testing. This is something that we didn't think about or something, right? It is going to be that less priority in terms of bug. Because if it's really critical, you should be able to find that immediately when you did your post-release validation. And there will not be a discussion even on the penal, having a QA person to take responsibility on that bug. Okay, they're just going to say, let's try to write more tests to prevent that kind of issues in the future, and that's it. There is no discussion. And surprisingly enough, you have two layers of protection when it comes about backing you up. You have engineering manager or engineering head, okay, and you have your QA manager or QA head. Both of them will back you up at all cost because you are very important to those two person. Engineering manager will make decisions to see which developer is performing very well based on your assessment, based on your work. So you find bug, let's say, so there is 5 developers you're working with. Somehow you find bugs all the time in John's story. And it always have that back and forth. 3-4 times later, John finally fixes it and he goes. The engineering manager now knows that John is lacking, into his responsibility. He may need some additional skill set. He will use this information to help John and say, look, let's have a discussion, let's talk, and let's try to get you some additional skill sets if you need, or work with somebody, work in pair until you are good on your own. And also there are hiring and firing judgment, and decision will go based on your work. Somehow a developer is not able to pass a user story. Somehow whenever you're testing, it's always failing and he's getting frustrated, things are not happening, and he's thinking that you will just go ahead and pass it, and it's not happening. After quite some time, the team will notice, they will hear from you, they will basically look at your documents, how many times it fails or pass. They'll look at the metrics, and then they will say, okay, maybe he's not the right person, right? So again, if it's a critical issue, it should not happen beyond the first hour, which is the hour you will spend to do post-release validation. If you don't find it, that means you're out of the hook, and pretty much you're moving on. Anything else comes in, okay, it's going to be low priority. I think Ruma has a question.
No, I'm good. Thank you.
All right, so discussion part, I'll give you guys, it's 12:05. I'm gonna pause here for like 5 minutes, right? And we're gonna come back exactly 12:10, and we're gonna continue from the next slides. But think about this, and then maybe some of you guys can, talk about your personal experience when you were testing or when you're actually dealing with any sort of softwares, and how this actually helped you to say, I am really, really, really interested in this kind of career. All right, guys, so I'll give you guys 5 minutes as a break. Break is necessary because otherwise you're gonna find yourself really not focusing. It's hard to look at the screen and try to understand a lot of things. So let's take the break. I'll see you guys in 5 minutes. Okay, so anybody want to share their personal experience? That would be great. If not, we're gonna move on. We do have quite a few slides, so that's why when it comes about interaction, I really appreciate your questions rather than having a large discussion about these kind of topics. The last question was here, that does this embarrasses you as a future software QA engineer? No, it is your job to find, basically these bugs. And by the way, when it comes about bugs, a lot of people are really afraid, and I'm talking about real bug, right? You see a bug and you're like, oh, I want to kill it. You want to rush to that kind of urgent situation. You want to mitigate that ASAP. But when it comes about a software bug, you will actually enjoy finding them. It's like almost like, Easter is here, almost like finding Easter eggs. You find a clue, you find a bug, and now all of a sudden you are the center of attention of the whole team. The whole team is talking about to say, for example, Juma found a bug and now they're going to talk about it. Oh, Juma found this bug. We want to see how we can fix it. We want to see if this is a legit or if there is a different way to handle it. And now they will invite you to different kind of meetings to make that kind of judgment. Juma, you have a question?
So I was so once I was using a coupon when we buy stuff from online.
Mhm.
So instead of like there were sale for 20% off, 25% off,
Okay.
but I was able to add 50% off. So I think that was a bug, right?
Yeah, and that's and I'm sure you were not the only one who discovered that. People that who did, maybe you also told your friends like, hey, let's do this. And now, yes, it's a great deal for you as a consumer and customer, but the company end up losing some money.
Yeah.
So yeah, that's great. That's a good one. Rima, you have something?
I think the one that we all encounter is probably when the website crashes on us,
Mhm.
or maybe when you make new account on your website and then you try to log back in, it says it's incorrect password, but when you change it, it also says you cannot use the old password when that's
Oh.
the only time you use it. So I think that's one of the major ones.
Yeah, that is a really, really annoying. And this actually happened to maybe some of us in the past. And what's going on inside is that under the hood is basically the data coming from backend is not coming fast enough, for example. And now you're constantly in a loop to change the password, and you got to give some time. But unfortunately, as a user, you shouldn't be waiting on the first place. That's developers should have thought about this ahead of time. And so yeah, that's really, really annoying bug. And this is the type of bugs that actually will be more critical than the other ones. Shoaib, you have something?
Yes, actually, I want to share experience.
Mhm.
I was using the Udemy website, and every time when I try to log in, like if I press the login button, so two fields shows up. One is email and password,
Mhm.
but after like 1 second, those two fields like shifting a little fur, and in the same place there are other buttons are showing up, like if you want to log in with Google, or if you want to log in with Apple ID or other software. So by the time I already clicked in the username or password field. So but when I didn't want to click in Google or Apple login field, but when I clicked, those fields already are not in there. The username password field are not in there.
Mhm.
So other fields are in there, and my click is actually when I click in the username, it's opening the other website, like it's clicking on the Google login page or Apple login page.
Mhm.
So there's a delay when those are login buttons showing. So I don't know, is it a bug or what it is?
If there is a delay,
Mhm.
you are the person, you're the QA to kind of make that determination.
Mhm.
You'll have to isolate the case and see if that is happening because your computer, or maybe this is happening because of your internet, or maybe this is happening because of the cookies or cache. And we'll talk about the cookies and cache, how to clear those, and what they are in the first place, right? You have to learn about cookies and cache as well. So it really, I cannot say 100% this is a bug. It could be on your end, but you as a QA will be the person to make that determination and then create the bug. All right. We have anybody else? Any other findings? Okay, cool. All right. So I hope this actually helped to kind of understand that as a QA, you're not less than a developer. If anything, you're more than a developer. It's easy to replace a developer, but it's hard to replace a QA. And you may say, wait a minute, you're just biased, this is your biased opinion. And I wouldn't say that, because this came from even developers. This kind of analogy came from engineering managers is because as a QA, not only that we do our testing, but also we are the subject matter expert onto that application, meaning we tested that application so much that we are expert. We know exactly how the application works. Somebody tells us, hey, I see this and that, and you can immediately say, okay, that's not an issue. This is by design. This is how it should behave, right? And that's why, you know, replacing you and finding another person coming in with like 20, 30 years of experience, he'll still have to spend 3 to 4 months before he can actually become a good, efficient tester. And that brings up to another topic is that you do get the first 3 to 4 months. You know, you don't really just go in and start to do testing right away. You will get some time to catch up. And that's why QA would be the right position to put your foot in the door, even if you're thinking to go into any other position like manager, engineering manager, or, you know, even going into DevOps, going into development as well. All right, so that's good. The next one is, if you can't say, you can't do it, right? So, you know, this is a very good way to put it. Specifications, you have to be very much precise what it is. You have to know what your product is before you can even say it has a bug. And again, like that goes into hand to hand with subject matter expertise. If you don't know the application, it'll be two things that you will see. Everything that you touch, you're going to feel like has a bug, or everything that you touch, you're going to feel like it's happy and healthy. Is because you don't know the application, you don't know the product, right? So that's why you have to make sure. Sorry about that, guys. Let me close that real quick. Great. So you have to know the application. You have to know the business. You have to know the business flows. You have to know the you have to pretty much know why a customer would use this product, what reasons, right? So being a subject matter expert will help. Otherwise, just simply going in, finding a bug, it's not going to be that easy for you. A specification defines the product being created and include. These are some of the documents that you will find. Functional requirement document that describes feature the product will support, okay? And non-functional document will be, for example, security, reliability, user friendliness, and platform. And user friendliness comes with design also. So these documents are provided to you so that way you can do your job. Okay. You don't wake up and then say, okay, I'm going to go into the application and make it better by finding issues. You will not find any issue unless you have these documents. We go by these documents, we look into it, we understand the feature, we understand the product, we understand the business flow, we understand the user flow. We then go into the application and try those business flows, try those user flows, navigate through the application, look for the functionality and non-functionality, and then come up with these bugs when we see that doesn't meet the criteria, when you see that doesn't meet exactly what we expected. Okay, so you read the document and you create expectation within you, right? And those expectations needs to be met, just like a home inspector. Okay, anybody here have a lot of money, let's say, and now you want to create, you want to buy a piece of land, you want to create a house of your dreams. You first find a builder and all of that, right? You tell them exactly how you want it. You have a list. You can't simply just tell the guy, I want bedrooms, I want this, and let them, you know, even if they do, they will write it down. For example, let's say you just don't have the time to write it down. So they will write it down. The contractor will write everything down and say, okay, I just want to make sure this is something that you want. If there's anything that you want to add, and you're going to say, no, this is perfect. This is exactly what I want. Now that list goes into, after the product is built, your house is built, the list goes into the home inspector. Home inspector comes in, and now not only he checks that exactly what you wanted it, but also he's looking to the realistic situations. Does the bathroom have a door so you can use it? You know, for example, does the bathroom has outlet? These are user friendliness right here in the bottom. Reliability. How many times can you actually, you know, use the door and things like that? What about the security? Can somebody break into the house and so on? So really, if you ever struggle to think about software and how you should be doing your testing, think about you as a home inspector who's going to get initial requirement from the homeowner, or maybe somebody who working with the homeowner, and then you'll create your checklist, and then you go in and not only you will check the items that is there, but also you will check for anything else like security, reliability, user friendliness, and platform. And then if you describe this in your perspective is a house, but actually you will be able to describe accurately how this will take place in a software. So just keep in mind, specification is really, really, really important. Otherwise, finding a bug is not going to be that obvious. Okay. And again, like just to emphasize a bit more, if you don't know the specification, then you're just going to be like anybody else that is using the software. So why should I hire you? Why not just hire an actual user, bring him in and pay them, you know, half of your salary, and they will do the testing, right? So think about that, the value that you are going to add by using your critical thinking and doing a little bit of extra. Be that critical person. You shouldn't be always be happy. Wow, everything is working great. No, you should be like, okay, wait a minute, let me check. 3 days later, you come back and say, okay, fine, it's working, right? You should never jump the gun and say, okay, good, thanks, done. No, take your time. Why do you want to make yourself go through and give people false sense of, security, a false sense of, hope that it's working fine, because you want to just do it quickly and make a lot of mistakes? The chances are, if you take 3 times the time that it takes to test, nobody's going to say anything to you, but also you're making sure that you are not under stress. It's very important that you're not under stress, so that way you can find and spot those issues. If somebody rush you, you got to tell them quality matters. You don't want to compromise quality when we are doing the testing. So just keep that in mind. This is something that we have to also use during the interviews. You always want to make sure quality is something that you're always seeking and trying to make sure it's maintaining quality. So let's talk more in terms of software bug, when that takes place, and basically the list that we have here is, if any one of the item within this list is true, then we have a software bug. We basically will have the software bug. So the first item in the list is that the software does not do something that a specification says and it should do. That means directly it doesn't meet the user requirement. Okay, user acceptance criteria doesn't meet, therefore you do not pass it. You create a bug. You create a bug, and period. There is no discussion here. If it does not meet the specification, there is no question, like, is it a bug? Who are you gonna ask, right? Yes, it doesn't hurt to ask, but that's very vivid. It's right there. It says that it should have this and it doesn't have it. Okay, so there is no point of going back and forth and asking questions, because you know for a fact it's a bug. Okay, maybe you can do a few things your side from your side, like testing a few times to make sure that it is in fact not there, just to make sure. But if it's obvious, but file a bug. The software does something that specification says it should not do. Okay, so this is just opposite of what I just said earlier. And it comes down to the specification, if it's there or not. If it doesn't mention it and it's there, then it's a problem. If it does mention it and it's not there, then it's still a bug. The software does something that the specification does not mention. Again, these 3 are pretty much hand to hand. So we'll go to the next one. The software does not do something that the product specification does not mention, but should, right? So basically, even if the product specification does not mention this, you'll have to use your experience within the application and say, wait a minute, I have a question. This is something I feel like is wrong. It needs to do this or that. So that comes and opens up more discussion with the team. You don't immediately find a bug. You don't immediately log a bug because you want to understand better. The software is difficult to understand and hard to use and slow. That is still a bug. If I click on, let's say, generate a report, or maybe if I click on add a friend, I click on that and now I have to wait 30 seconds plus and still spinning. That's a bug. I don't care, if it's gonna if it does actually do it, add the friend after 30 seconds, but still a bug to me. It shouldn't take that long, right? User will not wait around that much. Then hard to use. If user cannot even get to the feature and functionality, then they will not use it, right? And you want to raise these kind of issues, even if the requirement says the way it is developed. So you not only going to say, I'm going to check for this thing, but also you will use your judgment. You will use your experience that you have had over the years using application and softwares, and you will then apply those to say this could be better, and you bring up those suggestions. I would not ask you to create a bug right away if you feel like it's a suggestion rather than it's an actual issue. You would first ask and then you would then create a bug. Okay, so that's the way you're gonna go. But also in a team, go with the flow. Basically go with the flow, meaning if a team is following a specific way in terms of logging a bug and suggestion, you want to see how they are doing that. But in the core portion of your responsibility is this is what you should do. If they're not doing something like that, then you can practice on your own, meaning you can actually do this yourself, and you will see the support that you get from your team. And soon enough, everybody will do this. Everybody will follow, right? So if you bring in something to the table, which is good for the team and makes things better, soon enough, everybody else will follow in the team. Manager will notice and they will try to enforce everybody else to do the same. So you may be recognized for this kind of changes that you bring into the table. All right. Most bugs are not because of mistakes in the code. The code is fine. Everything is good. 55% of the bug are because of specification. I am talking about the requirements. I'm talking about the checklist that you get from the end user or the product owner or whoever is trying to build this application. And what happens is the ambiguity is there. One of the big factor, you'll see that they mention, I want this, but they don't mention where they want it. They don't mention what is the font size, what is the color, how it should look like, and all that. The other one is design, because in designers, it's easier to just draw and create something realistic, but it's harder for the developers to make that, make that a reality. And there may be some discrepancy there. Sometimes developer will hope that, oh God, I hope nobody finds this. There's this small, I'm missing the corner. Like, for example, if you look into the, on your screen right now, you see how rounded everybody's name in Zoom, it's rounded. And this is an actual issue that I found. And the design said it should be rounded just like that. And when I tested it, it is not rounded. It's like perfectly cornered. And so I raised that as an issue, and then developer came and like, oh, I just thought that he would probably let it go because this is so difficult to deal with. Now I have to write maybe a couple pages worth of code to make sure that this design actually is implemented, because those corners require very much a lot of work to make that happen, especially if it's an iOS device. They don't come directly like that. So, but anyway, we don't really prejudge any sort of specification to say, okay, this is done and it's actually going to go into work the way it should. Code 15% and others is 5%. So just keep that in mind. Where is most of the issue? Your priority is to read the specification, understand, ask questions ahead of time. And that's why QAs are going to be introduced very early in the development process, where you will see months goes by, there is no work. There is not even actual development taking place, because You don't have a physical product on your hand yet, but they're just talking about the requirement. And it's because, you know, you were there to also understand the specification, the documents and the requirements, and then you can not only understand, but also tell them if there's something wrong with that. But primarily you're there to understand the product. So when it comes about testing, you're able to do it efficiently. Okay, so just keep that in mind. And then you want to focus in the area where most bug you will be find, and the requirement will be the first one. Design document, it doesn't really hard to compare design with the actual, you know, application, because, you know, it's given, it's right there. You know, why would you not compare? Why would you want to rush it? Why would you want to go ahead and say pass, you know? Coding, you may not have a lot of control over, but if you don't see the issue, then you're fine. User will not see the issue. If you don't see the issue, then user will not see the issue also. All right, let's go into the next one. Relative cost of a bug found later costs more to fix. That is a fact. Okay, and that's why you are introduced very early in the development process, is because why this is more. Okay, let's ask you guys the question, right? Why bug found later will cost more to fix? You know, the developers are already there. They're already getting paid their hourly rate or whatever. But why is it going to cost 10 times more? Who wants to answer that? Anybody wants to try to make some guesses?
I want to say something.
Sure, go ahead.
If you find a bug in a specification, then all you have to do just change the specification or modify the specification. And if we don't find a bug during specification, and if we find during design, so we already did like middle of the design. So we already did some design prior to that. So we have to change. Maybe we have to change a lot of design we already did before. So this is gonna be also take time and also be costly. So I think this is the reason that we have to change so many things.
Yeah, and then it's just all about now what they have to go through to make that happen, right? If you found the bug the day the developer wrote the code and he says, okay, here, I'm done, and he found the bug, he will immediately be able to go to that code and fix it. Now everybody has to be involved. Now people has to agree to this kind of change. Now you know, a lot more time is going to be spent. Even the developers going back to the code, he's going to have to spend some time to understand what it is that he has to, you know, he was trying to do. Ruma, you have a question?
Yeah, I was just answering this question. So once you release the software, to find the glitch, you have to go through the process, step one. So it's better if you can find the bug while it's still in the process. That's why it's costs more when the software is released and then you find the bug. Then you have to go through the entire process all over again.
Right. Yeah, that's totally accurate. And yeah, and then that's why, like, the example, if you look into during the design, it's not as much. Okay, obviously the numbers are not right. $1 and $2, that's not the, just take that as an example. But if you find it during code, then it's still costing you more than design. And then lastly, after the release, it's not only going to cost you to fix, but it's also going to cost you some customer. Maybe some customers are frustrated. They choose to go with another company who has a better, you know, better software. Impressions, losing customers, but also having a bad reputation, that will also cost the company money. So that's why it's always good to find the bug early, and it's your responsibility to make that happen. And that's why as a QA, everything is a big deal. You find a bug, it's a big deal, period. You know, don't let anybody tell you otherwise. Okay. Bug-free software. Software is in the news for the wrong reason, because you're going to see nobody's going to coming up to the news and say, hey, this software in Chase Bank, I can just log in and make payments. I can Zelle and I can, you know, do all these things. Nobody's actually advertising that. But the moment you lose $1,000 from your Chase Bank because a software bug, because maybe it was security issue, hackers are able to log into your, you know, app, and be able to take out that money, all of a sudden everybody's interested to hear. Media is going to jump right on because it's really directly um, um, falls under the category of, okay, what about the investors? What about the people that are buying shares and stocks and all of that, right? So everything gets mixed in as soon as we have a wrong reason, security breach, any sort of, hacking situation, money situation, or most importantly, you will be frustrated. I lost $1,000. Nobody's helping. I'm going to go to the, news channel. I'm going to go and talk about this. And now you're making the whole company's reputation bad. That day, they're going to look millions, if not billions of dollars, because everybody's going to hear it. And maybe they're not going to use the app anymore because nobody wants to lose money. Or you could just go to social media and say, guys, stop using Chase Bank app because you lose this much money. Just go to the bank. Now they have to spend more money on tellers. They have to get more tellers and so, right? This is just few maybe minor examples, but again, bug-free softwares doesn't get a lot of attention here. Why can't software engineer develop software that just works? And that's the question, right? And that's why we're there. That's our job security. If they did that without our help, then we wouldn't talk about it today, and I wouldn't have a career, and I wouldn't teach you guys. But the thing is, think about that way. No matter what you build in life, somebody somewhere in this world will find an issue into that. You build something really, really nice, right? But somebody will be able to say, wait a minute, you could have done better. There are always things that you can improve. And when it comes about software engineers, when they write their code and they go through the design and specification, they don't purposely leave out any sort of use case or error or anything, any bugs because they want to. But it happens because they didn't know. It happened because there is a user somewhere in the world doing things differently, right? Maybe there is a user who says, okay, I'm going to sign up, and he signs up and then he goes to log in, and when he's entering his, let's say, username, his cat is walking on the keyboard, and cats love to do that. And now some special characters were pressed. And also at the same time, the enter button was pressed. And now you've just broke the software because the software didn't expect special characters into the first and last name. So really, when a developer builds a software, they can't really, have a control over what the user will do to that software, right? They can only fix and they can only predict what the user will do and then come up with solution for those prediction. And that's what we do too. As a QA, when we write our scenario, we predict what the user will do. And then we then test this prediction to make sure that when the user actually is using the application and somewhere around the world, one user does something very differently, is not going to break everything else. And that's what we do. We use our critical thinking. We use our product knowledge to do this kind of work. Okay. Now that brings in one question, like, what do you bring different to the table? You, instead of saying like, I know this and I know that, I know Java, I know, coding, I'm an expert. You can simply say, I am the type of person who will read and who will then match word by word to make sure that it actually meets the criteria. And over the years, this helped me, even this career helped me to be that critical. I don't really let go of this type of smaller or bigger, whatever issue that I find. But one thing that I can bring into the table after joining your company is that I will make sure that I find a way to break the system, right? That seems like better answer than saying, okay, I know how to write code, and I know this and I know that. Anybody can write code, but then the person who takes their time try to break the system has more value to me than somebody who has a computer science degree coming in and writing code. Okay, not everybody can do and have the patient to go through what I am just talking about as a QA engineer. So that signifies your personality. If you don't have the patient, if you don't have the way to look into the details, then you want to develop that during this class. Okay, during this process, just take that in one day at a time, guys, and think and try to be that personality. Now, for any reason you don't have that personality, even after finishing the class, when you go to work, trust me, you're going to make real world mistakes in the first 6 months, and quickly you will learn that you have to be that critical. Okay, moving into the next slides. Discussion. Do you think bug-free software is unattainable, right? Are there technical barriers to make that impossible? It is just a question of time before we can do this? Are we missing technology or processors? Any thoughts on this type of, I'll give some of you guys a chance before moving on to the next. Okay, anybody wanna, you can raise your hand. If no hands are raised, I will move forward. All right, Shoaib, go ahead.
In my opinion, I think it is actually possible to attain about free software, but for a limited time, not for like for forever. Like if I make a software, it cannot be bug free for entire of it is time, because every time I see, if I download this software, we all use software application in our phone and app or PC. So every time, it's time to time, like after 1 month or 1 week, when the they updated the software, the one thing we see in common, they fixed bugs. So what they did, what includes the new release, it says bug fixed. Bug fixed in this, in here, there, and everywhere. So I haven't seen a single software yet that says it is bug free for entire time, like for 10 years or 20 years bug free. So I think it's not possible actually to attain a bug free software, in my opinion.
Yeah, and that is a most accurate, I would say, accurate opinion there. It's really not possible. But I think Rima raised your hand. You want to go?
Yeah, I was saying it's not possible. There is no way we can create a bug-free software. There will always be an issue from user point or developer point. So it's not possible. It's totally not feasible to create a bug-free software. There will be issues, there will be glitches. We can improve the software, but cannot be totally bug-free.
Right. And it could be like, let's say somehow we have AI technology and we're able to write code so efficiently that there is no bug. But then what about the user requirement? Maybe the user didn't want that feature. Maybe the user didn't want that functionality. Maybe the user didn't want how it looks. So there's always going to be, even if we somehow, which is not, I don't think it's possible, at least from my standpoint, but even if we come up with that kind of technology that will, create softwares and allow developers to create software without any bug. And the part of the reason is because every time developers are writing or creating something, they are writing code from scratch. It's not like, okay, here is a component, I'm going to go ahead and add it. They have to customize it. They have to make sure that it meets the user criteria, it meets the documents that they got or design document that they got. So it's done very much from scratch, right? And the other thing is, and this is like, don't quote me on this. Basically, sometimes it's easier for QA to come back and say, hey, here are some issues. Because as a developer, and I used to be a developer myself, and when I developed a specific feature, I'm losing my nights. I'm doing day and night work. And it's because it's addictive, because when you write code, you just want to see the end product. You just can't wait to see it, like when it's done. So you're doing this kind of work, and then 2 days later, I'm so happy. I go to work and let's say now presented to Ruma and saying, okay, Ruma, you can go and test. And now Ruma is finding so many issues. And she's giving me a list of issues like bugs, and I'm fixing them one by one. Is actually easier than me spending 2 to 3 weeks to find those same issues, right? I can just focus in the meantime on another story, and Ruma can actually give me the list of issues that she found. So you will see over and over, developers will be comfortable to say, okay, go ahead and test it, let me know, or sometimes they will give you early access. Can you test it and let me know if there's any issue? And it's because they don't want you to create a bug. They just want you to let them know right away. But it's easier for developers as well to go out there, to work on something else. In the meantime, you find them list of issues they can fix. It's it's less time consuming when the bug was found and you know exactly the bug is originated. It's hard to find the bug. Okay, so it's really is a win-win situation for QA and the tester. So you really work closely with them to make sure that, both parties are working collaboratively. All right, goals of software tester. And again, know who you are and know what you have to do will really, really help you to go out there and talk about it and be very proud of yourself. Because when it comes about doing a job, or let's say you're a salesman, you can't sell a product unless you really, really, really like the product itself. You never use the product, for example, and you want to sell, you want to go out there and talk to people every day and sell it, you will see there's something missing. You will basically feel like, oh, I'm just pushing people to buy it. But the moment you use the product and you are a happy customer yourself, it'll be super simple. It'll be easy to sell. You will feel confident. You will feel like that you will really like your job. And so same applies here. If you don't know what software tester is, sometimes people people actually make this sounds like, he's just a tester. Oh, software tester. And it's because what's happening nowadays, right? What's happening is that out there, someone somewhere sitting down and think that they will, help people to go get jobs, and they're not signifying the job itself. They're just talking about STLC, and other things. But you coming fresh-minded, they're already making assumptions that you understood the importance of this role. And that could be one. That's really like not giving you enough information to kind of make you feel that this job is important, and you will have tons of fun, doing this kind of job. Our primary job is to find bugs, right? That's the primary goal, is to find as many bugs as we can. In the process of finding bug, we can make ourselves efficient by writing documentations like test plan, test strategy. We can write test scenarios, we can write test cases, and we'll talk about those, and we'll basically create these documents later in the class. But these documents, these processes that we use, engineering process like STLC, is to ultimately find the bug. So we don't really have to, we basically don't create them because we have to. We create them because it makes it easier for us to spot a bug, and it makes it easier to work every day, instead of saying, okay, I'm gonna magically just go through the application and find bugs. It's not easy to find, unless you have a plan. As early in the software development process as possible, of course, and make sure that they get fixed. So if the bug is originated during a cycle, it could be a sprint, and we talked about last time, then you want to make sure that gets fixed in the sprint. Otherwise, it's going to pile one after another. Let's say you find a bug and it's not being fixed. They can say, okay, put it in the backlog, put it somewhere, put it into the bucket list. And now the bucket list is growing and growing and growing, right? The other thing here is that an advice from experienced QA engineer is that be careful not getting caught into the dangerous spiral of unattainable perfection. And that is one of the thing that I will make sure, like, when do you say testing is done? Are you like kind of going and testing so much that you spent the entire amount of time that you're supposed to spend for 6-7 user stories, 6-7 requirement, and you just only spent on one because you want to look for 100% perfections? No, you want to think about, you want to use your, again, critical thinking process here and say, okay, which areas of the application is more critical? What should I be testing? What is in scope and what is out of scope? Meaning, what should you be testing? So if I'm testing, let's say, login functionality, right? And then while testing login functionality, I found after logging in, homepage have some bug. Do I go crazy? Now I go test homepage. Now I go test everything else. And I'm just running here and there because everywhere I see, I feel like bugs, bugs, bugs. No, you just finish homepage. If there is no bug in homepage, you let it go. You basically pass that user story and move forward. You go back to homepage and then you separately file a bug. You don't hold a specific requirement because something else is happening somewhere else. Okay, so you have to make sure that perfection is not possible here. 100% test coverage, is it possible? I don't think so. We talked about the scenarios where there are unrealistic scenario that you want to tell the team, hey, these are some scenarios that we cannot test. It's nice to, if we can test, that would be nice, but unfortunately we cannot test those two scenarios because it's unrealistic. No user will do this. So we're moving forward. That is 100% okay from the whole team. Everybody is human in your team. The important part here is that if you ever work in a team, this is probably the best possible career that you can have. Working in a team, you'll feel like a superstar every time because of your role as a QA tester. And you'll always see like developers, they always lay low, they're quiet, they just do their job. And somehow you did the testing and everybody's looking and like, oh, wow, Rima did this and Rima did that. It's just, you're not taking credit. You're just basically saying, okay, the whole team, kudos to the whole team, but also you were the last person who actually said, okay, everything is good. I tested it, everything looks good. Okay. So yes, you will feel like you are the center of attention in the meetings. You'll feel like you're centers of attention when you find bugs. And that's why this class that you will do for the next four months, I want you to open up. I want you to start to talk. I want you to start to tell us about how you feel and kind of get used to this kind of conversation, because 90% of the job will be remote. So chances of you guys getting a remote job is high, and you'll be working with your team remotely through a Zoom call. So try to open up, try to make sure that you are able to communicate, because this is something that you will do even after getting a job. All right. What to look for when interviewing someone for this position of the software tester. And this is actually, very early to talk about, but this is going to give you guys a little bit of idea what kind of personality they actually look for when you go out there and try to get a job. Are you an explorer? Meaning, if you somehow not comfortable going off of your road because things are done a specific way before and now you don't like the way it's being done, it's going to create an issue at the workplace, because there is something called continuous improvement. And so the team will decide what needs to be changed as process, what kind of documentation they need, anything at all to do your job. The whole team will make a collective decision to say, okay, maybe we can do this differently. And you should be able to explore and be able to then, kind of adopt to this kind of changes. Then you have troubleshooting. Like, simply, if you come back to me and say, hey, this doesn't work, it really doesn't help the developer. After all, you are still a technical person. Okay, you're not going to be everyday Joe who uses their computer for Facebook and paying bills. You're going to be somebody who is better than everyday Joe, who will be able to find issues and kind of narrow down to what issue that is. Even if you find a bug, you have to narrow down to say, I have basically followed these steps to go to this bug, and this is something that I've seen. So you have to be able to narrow down and give them precisely what happened and where, and the steps, the expected result, what were you expecting, and what did you get? What was the version of software that you were using? What was the browser that you were using? You know, and these are few items that you have to provide. So troubleshooting will be one thing that you want to get good at, as and we'll also give you guys training on that, how to be more precise on finding after finding the bugs and narrow down. You know, simply saying homepage doesn't work means nothing. You want to say in the homepage, in the corner of this and that, and you want to be more specific to the issue. Are there relentless, you know, are they relentless basically? So and that is something, right? Because you're going to be testing and testing and testing and testing, and you know, you don't want to quickly jump the gun, right? So that's really you need to make sure that you are that kind of person that you will always try to finish your task. You're relentless. You're not going to be, you know, going off the, you know, you're not gonna burn up yourself, like, okay, I'm done 5 p.m. and it's good, you know, and then tomorrow comes, I have to test this again. You know, you should be more curious and be able to fix, or sorry, be able to find issues and say how this software is working. Is it working well? And you should be more and more interested into the software itself. Are they creative? You know, creative is something that everybody look for in any kind of job opportunity that you can see out there. Even if I am let's say manager for McDonald's, I'll look for somebody who has a creative mind, because end of the day, you know, if you just simply do your job, you know, it's good, but then if you're a little bit creative, it really helps. It really helps to drive the initiative and be able to you know, keep the spirit up, be able to keep the motivation up, be able to take ownership. So a lot of the things that you will deal with at work, you'll have to be creative enough to find a solution, see, okay, maybe you can do something better, something differently that will actually not only help you, but also help everybody else. Are they perfectionist within reason? And that's the keyword, because the perfectionist is good, but like if somebody has an OCD situation, then they're going to be suffering, right? Because they're the one who's going to suffer, like, oh, this is not working. They will get really, you know, heated, and they will probably, you know, behave differently to the developers who's creating those features. Just signify the thing is that the developer may be spent day and night to develop that specific feature, and you're tearing it down in front of his eyes, like, okay, this is not working, that not working. And you're kind of like, you know, so you got to do it in a way that it doesn't hurt his feeling, because after all, that's his baby that you're talking about, whatever features that he worked in. And some developers do take it like that, you know, it's think about it, it's like almost like a game to them. It's like kind of, even for me, like when I was developing features and functionality, I would think that, okay, I'm going to spend the next 2 days trying to get it done. And then I'm going to spend more time just relaxing because I want to get it done, try to see how it works, and then spend more time with the end product rather than doing little by little at a day. So it gets addictive at some point when it comes about coding. Do they exercise good judgment? You know, you should be able to adapt to the change. You should be able to judge, because you cannot go to your manager for every single item that you find, every single bug. Oh, is this a bug? Is that a bug? No, you should be able to make a decision based on what happened prior. You know, you shouldn't really ask the same question twice, to be honest. And in this kind of, because everybody's super smart. When you work in this kind of environment, you'll quickly realize everybody's like super smart. You'll be working with people that has MIT degree, somebody who actually went to MIT, somebody who went to Columbia, and your CTO will be one of those Ivy League, you know, university graduate. So when you talk to them, you will always learn something new from them. But the thing is that, you know, you want to make sure that you are not asking the same question again. Make a good judgment based on what happened previously, but also try taking notes, so that way you don't have to ask again and again and again. Try take videos, so you don't have to just go ahead and ask him, like, can you show me one more time? It's kind of annoying, but also it shows that you're not professional. If you think you're going to forget, why don't you write it down? If you think you're going to forget, why don't you just take a video, take your cell phone out, do a video? Whatever helps you to do your job, I would say do it. Are they tactful and diplomatic meaning when they are expressing their feelings. Let's say you're in a meeting and let's say, Shimona didn't show up in the meeting, and earlier in the day you guys were chatting, because at work you'll be chatting with your coworkers all the time, and you guys probably will have a fun channel. So now, like, let's say Shoaib is talking to Shimona, and they're like talking about like things like they're gonna do maybe like some concert or whatever, and Shimona mentioned that, okay, I'm gonna go to this concert at this time, and that was the time that the meeting is happening, and Shimona didn't tell anybody and just said I'm sick, and left. And now Shoaib goes and say, oh, it must be that concert, and tell everybody. That's not nice. When it says tactful and diplomatic, you want to make sure that you don't really try to expose people like that. It's not about the exposure, it's also the privacy. If somebody trusts you and they talk to you about something, don't ever bring that up to the whole team. But most importantly, in this kind of team, what the HR and other your managers, they look for people that are toxic, meaning they always talk uncomfortable situation about somebody else to other coworkers. They always look for this type of people to fire them. You go to your manager and say, hey, Shimona has been taking time off to go to this concert. If the manager is really, really decent, you'll say, wait a minute, it's her time off. Let's not talk about it. But then the manager already knows your personality. You just told him how you are. Okay. If somebody's late to the meeting, you want to tell them, oh, maybe they're busy. I don't know if their internet is, working at this moment, but give them some time. Always be moderate. Don't, because by getting fired, it achieves nothing, right? By getting somebody fired, you don't get extra few dollars. In fact, you will get more work because you just got that person fired, and now you have to do their job too, right? So it's good to just be more diplomatic, not going out there and fall into the office, what's that called? Politics there, right? You don't want to get into this type of things. Always talk highly of people. If they did something good for you, just, give them proper credit, give them proper, pat on their back if they did that. And that will be appreciated, because the other way, in terms of talking to, people or trying to get people fired, really, really helps nobody and no one, because you're not getting extra dollars, you're getting extra work. So it doesn't make sense. And here, everybody's super intelligent, and some of them are super professional. So you'll see, like, when they talk to you, they will always follow up with an email saying, hey, so we spoke about this, so let's do this and that. So you want to be that kind of professional. You want to be able to communicate effectively. And that is not, I'm not talking about English, I'm talking about emailing, I'm talking about instant messaging, I'm talking about be able to let them know, hey, I'm going to be busy the next 2 hours, or let them know that, hey, I'm going to take 1 hour in between off because I'm going to lunch, a long lunch with my husband or whatever, with my boyfriend. But either way, this kind of behavior will help you, because sooner or later, if you want to be a manager, guess what? Everybody has to like you. It's like almost like an election. If nobody likes you and they have negative things to say, you will never be a manager. Personality of a manager will not show up, because you feel very differently about other people. And over the years, if you ask me, I worked with people that really, I know for fact he's not doing the work. And for fact, I know that these specific tasks that I assigned to this person should take 45 to an hour. 3 days later, they come back and say, I have an issue. And I don't tell them like, okay, how come you telling me after 3 days? Why don't you tell me like 45 minutes later? I don't put people on the spot like that. If they came back 45 minutes later, okay, that's fine. That's total. Sorry, if it came back 3 days later, that's totally fine to me. At least they came back with an issue. So just think like that. There will be slackers. There will be people that will be highly attentive to work. The ones that are highly attentive, they will start to take a lead unofficially, and then they will be recognized, and they will probably become a lead at some point, increasing salary, and also be able to keep the job and not get replaced. All right. So now basically, these are a few things. We're gonna take one more break because I want to give you guys enough break. I think today we have the time until 2, right? So we'll take one more break. But what do you know now? What is a bug? So I'm gonna start asking you guys some questions because let's see if we can answer these questions, right? One by one. I'm gonna start choosing people. So that way you kind of get forced to open up a little bit. Okay, so Shimona, what is a bug? What do you think is a bug should be?
Parasite.
Okay, Ruma and have her hands up. So I'll get back to you in a bit. So Shimona, if you have a chance, I'll get back to you also since you're muted. All right, Ruma, you want to answer that question or you have another question?
Oh, no, that was a mistake. My hand, I forgot to take it out.
Okay, that's fine. Okay, Golam, you have a question?
Yeah, I was a little late to the class, but my question is, the bug, usually we believe that well, which can bite you. but but in this case, bug is like a wrongful coding, which can interrupt into the application or software, which can turn down the system. Or it can block the further explanation of your software.
Right. And it is anything unexpected. It could be anything that is not mentioned. Even if it looks good, it works good, everything is fine, but it's not mentioned in your requirement that is given. A checklist that you created doesn't have that. That is still a bug. So give you guys an example here. Right, so let's say you are the home inspector, you go to the house and the owner mentioned all of the items that you're supposed to check. As soon as you go to the, let's say, bedroom and you see a jacuzzi, it's very nice, refreshing, and bedroom has that, you know, and it's nice, it's expensive and everything. What do you think? Is that a bug, or do you think this is something that, okay, no, this is nice enough, the owner is going to appreciate it and it's good, you know? What do you think?
It's a bug.
Yeah, it's still a bug. But now once you report the bug, the owner can choose to fix, owner can choose to keep. It's really up to them.
It's a
We
bug.
have to do our job, right? We have to say this jacuzzi should not be in the bedroom. It really, you know, it's nice, but unfortunately it's a bug, right? So that is just a small example to say what bug should be. So everything is a bug unless it's proven, meaning you went through your checklist and everything was working fine. Rima, you have any question?
I just want to say that every addition that's not in the plan of the business analyst or product owner, whether it's good or bad, if it's not pre-approved by them, you cannot take a risk as a developer to add something on. And what if they don't approve it? Then everyone has to go back to the same process of doing the same thing just to remove it.
Yep, totally makes sense. It's great. At least few of you guys that are speaking at least tells me that you guys did grasp this material, and it seems like you guys are really understanding, which is good to hear. The next question is that the relationship between specification and the bug. Why, you know, again, and this is, we just talked about, right? Specification means the requirement or the user stories. And this is something that we cross-check. We basically created our checklist based on the specification to see, okay, if the bug is, if it's in fact a bug or not. The cost of the bug relative to when it is found. So we also learned about, you know, is it good to find bug early versus later? Later is going to cost more to a team, which you may not see it right away, but then it is costing the company that money. So anything to save money, the company will try to do. So you will be hired in the very beginning stage of a software if they are building a new software. If it's a maintenance, then you will just join and you'll continue to work on the maintenance requirements. The unattainable goal of a perfect software. So we know 100% perfection is not possible. 100% testing is not possible. And there will be some things that you'll have to say, this is something maybe and maybe 1% of our customer will do, but we're okay with it. We'll just leave it as is, because not everything that you will find the developer will fix or be able to fix. Maybe the technology is not there. Maybe there is a technical difficulty when it comes about fixing that issue. They will leave it. There will be some bugs you will see that, financial companies, they're okay with it. They know they're losing money, but they're gonna be like, okay, that's fine. Maybe a small percentage of people end up being, slightly richer by this small loophole, but we're okay with it. Fixing that loophole will be more costly than paying up. Okay. Sometimes you'll see that the companies, they take lows, they get a lawsuit and they end up paying up. And that's okay. They already know they're gonna have to spend some money. It's okay to lose that money because they missed something on the, on the product or whatever. The customer wasn't happy, and it's okay to do that. They already know there will be some issues that they cannot fix. So we talked about that also. The goal of a software tester, I think, at least in my view, is very important that you guys know, because moving forward, when we do our feature classes, the next class, you guys will go deeper and deeper. Every day, this class is going to get harder and harder. We started at the very bottom of this is your first step, right? So every class, you're going to see slightly increase of, complexity. And when you see that, you want to make sure that you're getting things done day to day. You don't want to pile it up, because when you reach your 5th class, you're going to say, okay, I'm lost. It is easy to get lost, because again, if this was easy, then everybody would do it. Okay, so let's go into that. Valuable attributes of a software tester. And you want to know who you are, and you want to know what kind of attributes that you should have. Somebody with a clear mindset, somebody who knows exactly how to find issues, somebody has an eye for a tester, and being a critical thinker is really, really helpful. Being patient is really, really helpful. And start practicing that. Anytime you see something on the web page, just read and understand before moving forward. You're doing an application and it's saying like some fine print, and you say, okay, nah, whatever. Continue, accept, right? As a tester, we don't do that when we do testing. We actually read through it. We actually compare to make sure that the text is correct, and then we move forward. All right. And then when you become efficient, you will know what to skip and what not to skip. Obviously, everything testing at the same time it shouldn't be that way. Okay. So now we are talking about the development process. Before I go into the next chapter, what we will do is that it's 1:14. I'll give you guys another 10 minutes break. Some of you guys probably already feel kind of like sleepy. I don't know. Maybe that's the case. For me, it's like I'm speaking, so I can keep going. I don't feel sleepy because, when you are actively speaking, you have goals. You want to go through a few things. But some of you guys are listening in probably will have a hard time. So I'll give you guys some time to go and get some fresh air. Come back at 1:30. You have 15 minutes break, and then we're going to spend another half an hour. Hopefully by that time, we'll be reaching to slide number 35. So I'll see you guys at 1:30. I'm going to pause the recording here. And when you come back, bring any questions if you may have any questions. We'll talk about those first before going into the next chapter. Part of the slide. So software development process, and there are two things that you really, really want to pay attention to in order to become a software tester or software tester at heart, somebody who knows, what they're doing in terms of job. Software development process is something that you want to make sure that there is no doubt, make sure that you really understand what it is and what are the stages and how some of the methodology of software development process is. So we're going to talk about that. I think we also covered this previously into the previous classes. If you weren't there, don't worry about it. Everything in this material is intended for the first ever class, so I shouldn't be surprised But for those who did have some glimpse before, it'll be easier to understand. So software is basically requirement specification document. We have design document, source code, test suite, and test plans. So these are some of these element actually makes what the software is. In order to make that happen, we need to have a requirement and a specification document that really list out the feature and functionality, business process, and what it is the software should have. And then we have design document that really complements what the requirement should be. So based on the requirement, design team, they will design it. But when they design, they also make decisions based on the company's standard. They make decisions how it should look like, and somebody will have to make decision on the color, font size, and all of that. So the design document actually is another requirement document, let's say, because they do go through series of approval process to make sure that the company is okay with, or at least the team is okay with this kind of design. Sometimes they will give you design demo. So design team will go ahead and go over each and every single design that they have created to make sure that you have the opportunity to correct anything that you see may be problematic later. Then we have source code. Source code is basically just coding, writing the code in order to convert the requirement and design document into a interactable software. A software basically make things happen with code. Design is just for proof of concept. It doesn't have features or functionality. You just see it how it looks like, just like a screenshot. And then you have requirement, it's just a document. But the source code is something that allows customer to use the application and be able to do their everyday business, depending on what kind of software that is. The next thing is, once the source code is done, we create test suites. Suite means basically a series of tests. It's not just single test. So we create test suite and test plans. So we basically, I mean, there is a process of creating this. There is an engineering process of testing, but here we just basically list out what we need to create. So we have a test plan, and after that we create the test suites to make sure that we covered enough reason within the reason after looking at the requirement, understanding the requirement, and tested the software. Then we have interface and hardware and operational environment. So what happens is that once the software is tested, it then goes into a production-like environment that goes into a specific environment where they check if this is a iOS or Android, or if this is like a tablet kind of software, then it goes through those hardware, operational environment to also see how they work in real world scenario. Then we have internal, external documents. Internal meaning like whenever you have a software that is being used by employees in a company, they will create a training document where the employee will get training before even release goes place. Otherwise, everybody's going to go home and not work. That day, they will basically say, okay, everything is working very differently, and maybe it's a bug or issue. But you want to give them proper training, and you may be involved as a QA to create the training materials. So that way the company can do the training to their employees before using the software. Then external document is just the release note. If you ever go to an application and they have like section versus release, upcoming release or release note, or if you go to iPhone, you'll see there is release note. For any of the app they release, they usually provide a list of items they have improved, right? So that needs to be done before even releasing to the public. Executable program, their persistent data, right? So that's just basically software working as intended. Software effort, what kind of effort that will be made throughout the whole SDLC process, the software development process. We have specification, meaning we have the requirements. Then we have product reviews. So there will be multiple reviews after the specification is done to make sure that specification is correct. Otherwise, everybody's going to end up building the wrong thing. The design is the next item after the review is done. Once the design is done, then they will create a roadmap, which is like a scheduling, and to say when things are going to be done. This feature, I want to get it done by August, something like that. And then they will give a time frame, deadlines and schedule that according to the team. Feedback also part of the development process. Whenever there are changes, user use that and then they come back with feedback, or even the feedback comes from QA, feedback comes from the engineering team, or even feedback comes from the product team. Whatever is the case, it will be accepted and looked into. Competitive information acquisition, and then we have the test planning, customer surveying. Test planning is really our part where we end up thinking about everything that we'll need for testing. What are the scope, what to be tested, what not to be tested, and when can we say testing is done. So we list out all these items in our test plan. And customer surveying, basically you're constantly looking for customers' feedback. And that really depends on the application that you're trying to develop. And if you do get customers' feedback, then that will be used during your development process in order to make it better. Usability data gathering. Test data is basically one thing that what kind of data do you need in order to continue testing? Do you need login information? Do you need to create a user? And how much control you have over that kind of data? So you can make it, you can change as need if you need to do testing a specific scenario. Look and feel specifications. So look and feel is like theme that is coming from design team. So they are the one who's responsible for that. Software architect and programming. So software architecture is basically a software architect will be the person who's making the decisions on what approach they will take. So just like a QA architect will make decisions on what kind of process will be placed in QA team, what are the tools to be used as a QA team, and so on. Software architect will do the same for their part. And lastly, programming, writing code to make things happen. So now discussion is, what is software engineering? What does testing, where does testing occur in the software development process? So let's kind of get some of the thought before we move to the next slides. And I'll try to get these slides through because we have reading assignments. So I'll try to get everything through by 2 p.m. So we're out of here. And then next class, we will talk about these items. And I'll give you guys the homework. I'll give you guys in writing what I'm expecting from these slides from you guys. So I'll probably just give you guys questions for you to write the answers. Okay. So any thoughts on this? You guys want to discuss more? All right, I'm gonna pick one of you guys. It shouldn't be always same person. Okay, Juma, can you go? You can.
Yeah, so the software engineering is basically we do the testing to match the expected requirements and make sure it's a bug free.
Yeah, software engineering is like the overall. You have mentioned only the testing portion, but then overall, like talking about specification, design, you know,
Okay.
and
Coding.
development, coding,
Yeah.
testing, all of it.
Okay.
Okay, and then where does the testing takes place in the whole process?
It's from the initial points.
Yeah, you can start working from the initial point, but actual execution of tests will happen when the code is delivered.
Yeah.
But you can still do it from the very beginning because early feedback. Cool.
Okay.
All right. So moving on to the next slides, and all right. So customers requirement. When I say customers requirement, think like end user. The software development team must determine what the customer wants. How can you do this? Guess, you know, it was the one option you have. Collect detailed information from survey, get feedback from previous version of the software, read reviews and magazines, you know, get information about the competitions or other ways. So there are, you know, these are questions, but again, the possibility, the guessing is probably the only one I would stay away from. But sometime even with the educated guess, a company can developed software that will help them generating more revenue. And then we have the collected data used to guide specification effort. So these are some, again, like these are some data that we, the team will use. Sometimes they will use analytics from Google to understand where the customers are spending most of their time. So they will refine that part of the software to make it better. But these are some way that the data can be gathered to see the business decision can be made in terms of what the next new feature should be, what the application should be, and the specification should be. But as a QA, as a developer, we don't make that decision. That comes from business. They use this data to make decisions what to, what features to add and how to improve the existing software. Then we're talking about specification. Again, this is just requirement. Again, if you don't know where we're going, then any road will take you there, right? So that's the problem, right? That's just a code from, I don't know if I have somebody's name here. No, I don't have it. So specification. So if you don't know where you're going, any road will take you there. The specification takes the data from customer requirement and then other source of defines the feature of the software, functional requirement, the constraint of this feature, which is non-functional requirement, and the specification can be formal, informal, a napkin or whiteboard. And this is exactly what I'm talking about is when I said a product owner can simply say, oh, I would like to have this, I would like to have that, and they don't have to give them a document. The business analyst will be the person who will write that document based on his understanding after talking to the product owner. So it's a formal, informal, and it could be just simply writing a piece of paper and giving it to the product the business analyst. So the requirement, how it comes, this is one sneak peek on how the requirement can originate, but we more focus on testing and we just go based off of the requirement. The requirement is our source of truth. We don't really look at the application and say, oh, it's working fine, so let's just keep it. Even if you like the feature, you can say, okay, it's fine, but this is not what we actually even have there on our list. Schedules. So the goal of scheduling are to know what work need to be completed, and this is really project manager, this is really the scrum master in your team. This is not your responsibility, but again, you need to know, so that way you have the proper expectation. What is the need to be completed? So urgency, priority, right? Severity, this is something that they will determine. How much work is left to do? How do we even determine how much work is done? And so if you look at the overall work backlog, and then if you look at how much work was done the last 2 months or 3 months, whatever it is, then you can kind of guesstimate how much work is left. When will the work be finished? And then when, who will finish each task? Other measurement will be done. Also, a Gantt chart is basically just a roadmap, let's say, and a roadmap is to pretty much create a bar and providing scheduled time when each and every single feature will be done. So the next one, we can see how the roadmap looks like. A project roadmap looks like this, where they said this is a feature they want, and then the time will be in the top, like from, let's say, March 30th to September 1st, this feature should be done, and so and so. And if it's done timely manner, it'll be a different color. So there are tools for that. And they are pretty much measuring if pretty much things are done correctly. And they will also have to do some sort of preparation. If there is an extremely useful feature is coming, they want to let their customers know, we have this specific feature will be released in next month, so this and that, right? So that's really, really helpful for sales team if that can be kind of estimated. And this is kind of like the roadmap that they use in work environment. Now let's talk a little bit more about the design. Again, design team has a lot of freedom in terms of designing, and they're pretty much going to get multiple approvals before even designing this. Sometimes they will change the face of the theme the whole company has, meaning they'll come back with like a theme that will change for entire company. So they do have a lot of leverage to make this kind of decisions, but then they do it collectively, not just single person coming in and making this decision. They will have to convince the team, they will have to convince the higher ups to make sure the design makes sense. Before coding begins, non-trivial software project, sets of design documents are created to serve a blueprint, software architecture, data flow diagram, then state transition program flowchart, and commented code. So this is how the UX design looks like right here. This is how the database, like where the data coming from and how this will pretty much, so the picture in the corner that you're looking in, it's like a representation of that data flowchart. And then the pink picture pretty much gives you an idea of how the design looks like for UI and UX. And these are some decisions. So UX design, as you can see in the bottom, they decide navigation bar, what they should be, structures, design, all of that is done through UX designers. And they keep all of this in mind before making the design decisions. We only have 5 more slides, so I know it has been pretty, long class, lengthy class, so bear with me. All right, source code is the next. And again, we're just going through each one at a time. Source code is basically the ultimate specification. This is where we come in and say, okay, let's do the actual testing. Let's see the actual end product, if this is meeting the criteria or not. And many programming languages or tools to choose from, but the software architect, he will let the team know which language to use and which tool to use in order to develop that kind of software, the coding part. And now we have test. So this is where we feel we should be more comfortable in, right? Test documents. You got yourself a test plan, which consists of quality objective, what kind of quality you're targeting, resource needed, who's going to be working and what areas they will be working in, schedule assignments, what should be done and when, priorities basically, and methods, what kind of testing methods that you'll apply. That mean there are many testing techniques out there that you can apply to be more efficient with your testing, and we'll talk about those. So that'll be in your test plan. Then you got the test cases. Test cases is basically describing step-by-step process on how to carry on with the testing. So you're going to say something like this. User goes into the home page, then user clicks on, let's say, registration, and then after that user enters data, required information, first name, last name, whatever, their email address and phone number, and then user will click register. After that, the user should be able to register with the required information, for example. So you'll describe all the steps. So go to this website and then enter this information. So you want to write your test cases in a way that anybody can follow and be able to execute, be able to test it. Next is bug reporting. When you execute your test, when you actually run this test, you should be able to find bugs. And then you want to create those bugs. You want to basically track them until the bug will be fixed. In order to track it, you have to use a tool. Here listed as Bugzilla, which is a tool, but we're going to be using another tool called Jira, and that's what we're going to give you guys training on, how to create bugs, how to properly write a bug, and then track it to make sure it's fixed. Then for test automation, we have we'll basically use Java with Selenium. Selenium controls the browser. Java is the language that Selenium listens to. So what we're going to say, Selenium, please go to this website, and we're going to say it with the language that Selenium understands, which is, let's say, Java in this case. So first we have to learn Java. Second, we have to learn Selenium in order to do test automation. And that's what we will do also. And that's why I said this class is going to get harder and harder. And I need people to focus, even if it's harder for you to focus here at this point. The only time you're going to be super focused in the class, or I guess like the most of the time, is like when we do practical work, when we write some code, when we basically do the actual testing. We have to make sure that introduction is done through the slides. So that way we kind of have the background information. We know where we're coming from. We know exactly what it is. And then once we write some test cases, test scenarios, we're testing an actual website, we're going to get more hands-on and it'll be more interesting. So when you do see classes that has slides, just work harder to make sure that you can focus. Then we have metrics, statistics, and summaries, which shows how many bugs originated, how many test cases you wrote, how many test cases pass, how many test cases fail, and so and so. So these documents that will be part of your everyday work. Going into the next slide, if you guys don't have any question. The next slide is basically just describing about some of the position in your team and who will be responsible for what. And that is essential for you to know, because then you know exactly where, what you need to do. So first position is project manager. Project manager basically writes product specification, manages the schedule when things should be done and what should be, he also does hiring and firing, whatever needs to be, any concern the team has, critical decisions like trade-offs, or even acquiring new resources or new tools in the team, if that helps the team. So then we have the next one, software architect, system engineers. So basically they are the person who will design the software, who will think ahead of time, come up with a plan to say what language to use, what approach that they should follow in order to build that software. After that, the next role is programmer, developer, or coder. These guys are like the frontline armies, right? They are the one who's going to write code and fix bugs for you. So they will be your mate in terms of working very closely. That's the coworker that you want to reach out most of the time during your work. Then we have the testers and quality assurance stuff. So this is you, QA engineer, QA tester, QA analyst. Find bugs, document bugs, and track process of open bugs, right? And that these are asides from, this is your primary responsibility, but the documentation, don't forget about those, right? Test case, test plan, we have to create those. Technical writing, write manual on and line documents. So if the company is big enough, like Facebook or something, what they have a technical writers who will look at it, understand it, look at the change, and then he will start to write manual, he will start to write training documentation. But if the company is small enough, they will ask you to do this kind of work. Configuration managers and builders, they're just responsible for taking the code from developers and putting it into a server so it works, right? And then people can use, right? That's it. CMT, configuration management team, they will make sure that all the connectivity should the software have, it has, and also if it is properly done and installed into a server. We got two more and almost done. These are just pictures. So I think we're almost time, 6 minutes. I think we're very much on time, which is great. Software development lifecycle. We got two different type, and we're going to talk about both. I think we did talk about Agile last time. If you were there, if not, then we can share the video. Just go ahead and let us know. We got two methodology, waterfall, agile. We're going to focus on, as you can see, waterfall is simply one done, then going into next, one after another. There is no way to go back. But then in agile, what we're doing all of these within a specific window. It could be 30 days, it could be 24 days, or it could be 2 weeks. We're dividing the work into smaller pieces, and we're getting the smaller pieces done within a smaller time frame, and then releasing that smaller piece. Compared to waterfall, you'd get the whole product done, tested, verified, and then goes into the deployment. All right. Today, after these slides, after this session, what you now know. First, what is a software? Second, what software engineering is. Third is, what is the composition of software development organizations? You know who are they, you know how it takes place in terms of doing everybody's responsibility within the software development team. What are the major phases of software development process or project? How major phases are organized pretty much, like the coding, the design, the testing. All right. With that said, we're going to leave some time for questions, and we're going to end the day. So any questions you guys have?
Yes, sir. This is Ghulam. I have a question.
Sure.
Question is actually very confused. This is the class, this is the new semester, the new session began.
Yes.
I mean, I didn't do the registration yet. What
That's
about?
fine. I think we did send out a text message that registration taking a little bit of time, because what we're doing is somebody's calling you guys one person at a time to make sure that you have a proper understanding and expectation, and also some items that he will talk about. And we talked about this in the group, that even if you're not registered, you're going to be able to do the next few classes as long as you have the interest to join us. And momentarily they will reach out to you and make sure that you have you're registered. Yeah, so we just don't want people to miss the class because they took some time to register. You know, it's on our end. Usually weekends Mohsin is going to reach out, or usually but sometimes people just go ahead and reach out to him, and when he's free he'll go ahead and talk to you guys. But yeah, it's a lot of, he's dealing with not only one badge, we still have other badges. So that's why it's taking a little bit of time, but don't worry, you can continue to do the class until you're registered. So everybody should be fine.
So the class class is scheduled to every Saturday, and which day?
Every Saturday and Tuesday. And for the month of Ramadan, we're going to have a different time for the Tuesday. I think we shared, I got to look at the time real quick. Shanto shared with the group, but we'll give you guys one more notice on to the time for both classes.
So this is the first class for this new semester?
Yes, it's the
Okay.
first of our class. Yeah. If you want the last two classes that we did, just let us know. We have the recording. If you go up, you're gonna see that we shared the recording and previously. If you wanna just go through those, because those are like overall. We're just following right now the course material. We're going one topic at a time rather than jumping into multiple topics, what we did in the beginning. This was just to make sure that you have a proper expectation and understanding of what to expect from this class. But now we're going to just basically go into, like, slowly we're going to go into topics that you may find it harder, but we're going to go as slow as we can to make sure everybody understand properly.
Okay, no problem. Thank you.
All right. So with that said, if there's any more question, we'll talk about it. But otherwise, I'm gonna send out you guys the homework, the reading material, like which pages from this slide you guys should read and come up with and do the quiz. And yeah, that's pretty much it. If you guys have any question, just post it in the channel. We'll try to answer as soon as we can. Somebody asked for curriculums. We do have it. I don't know if we do not share yet, but Mohsin will share with you guys when you guys already talk to him. If I think those already who talk to him, if you don't have the whole 4 months of curriculum, we can definitely share. We'll probably put it in the group so everybody have it at the same time.
I have a quick question. I'm sorry to
Sure.
interrupt.
Yeah, sure.
So when you talk about Selenium and Java languages, are you talking about beginner, intermediate, or what type of knowledge one should have for this?
So we're gonna give you basic training in Java, because if we try to go in advance, it's gonna take a lot of time. Java is not a small language to kind of grasp within the 4 months of time. So what I usually do is give you the basics, like you learned how to move around and navigate through the language, create some small programs. After that, you learn how Java is able to use Selenium to write the test automation. So anything that you need for writing automation tests, you'll be learning. So you'll be learning as you go also. So after the initial training in Java. We're going to continue to train you guys onto the bigger topics. Some, I would say, more complex features of Java, but we're going to do it while we're teaching you the test automation as an example.
And these are the only two languages which needed for this course. Like if someone knows, have a little background in other language, that's not going to work.
No, 100% is going to work. Any language. If you know a programming language, any language, right? It is going to help because the fundamentals is same. The algorithm, we're talking about data structure, we're talking about the way that you're supposed to create a program. It's going to be same. The fundamentals are going to be same no matter what language that you have ever used. But you're going to enjoy learning if you do have some background in programming.
Okay, thank you.
You're welcome. All right, so let's not take more of your time, guys. I'll give you guys the Saturday